chapter 4, section 4. And notice that it's a logarithmic equation, and they have some in here, some instructions about ignoring any value of x that's not in the domain of the original expressions. So let's get a solution set, and then we'll see if once we think we have the solution set, if we have any values that give us any domain issues. And so I've written this out on the pad, so let's look at this together for a second here. Now, this is the problem that they gave us. Log base 10 now of x plus 8 minus log base 10 of 10 equals log this expression over here. And so what I did is I went ahead and just used the quotient rule to collapse this down. I get to the point now where what I have is I have a single logarithm over here equal to a single logarithm over here. Now, the one-to-one property for logarithms tells us that if you have same base, you have two logarithms that are equal to each other, single logarithms that are equal to each other, the only way that can occur is that the arguments must be equal. Simple example. If I tell you that the log to the base 10 of 100 is equal to the log to the base 10 plus log to the base 10 of 10, well, you know that this is 2, 10 squared, so this is 2. And this over here, 10 to the 1 is 10, plus 10 to the 1 is 10, 1 plus 1 is 2. Now, when I collapse this one down, you can tell automatically that I'm going to get 100, 100 here. So when you have the same base for the logs, the arguments must be equal. So therefore, and just one other way to think about this, I tell you that if I were to write this in exponential form, I would be telling you that there on this side there's 10 to some exponent. There's 10 to some exponent, which equals 10 to some exponent. You with me? So in other words, the exponents, and what would the exponents be? Well, the exponents would be the result of this log calculation. And so if the exponents are equal in terms of an exponential function, then we can make the same connection that, well, this argument here must equal this argument here. So at any rate, what we wind up doing is we wind up getting something that looks pretty easy to solve. And I think the first thing I'm going to do is multiply by 2, and that's going to give x plus 8 equals 6x plus 2. You with me on that? Subtract from both sides, subtract 2 from both sides, and then I get x equals 5/6. Okay. Now, what they asked me to do was to determine whether or not, and let's see, did I do this right? Okay, so I multiplied through 2 here, I cleared out the 2. This became 6x plus 2. Then I simply said, well, subtract 1x from both sides, subtract 2 from both sides, and then I get that when I do the division here, I get x is equal to 6/5. That didn't look right. I thought something was on that. X equals to 6/5, right? 6 divided by 5, x equals to 6/5. Okay, now if we go back to our original problem, do we have any domain issues here? Well, let's go back and see what we get. We're going to get that the log of 6/5, I keep wanting to write that 5/6. That the log of 6/5 plus 8 minus the log of 2 equals the log of 6/5, 3 times 6/5 plus 1, right? I got all that right. Log of 6/5 plus 8. No. What have we got so far? Well, if we do this little fraction arithmetic and see where we're heading here, then this is going to turn into 40 fifths. Yeah, 40 divided by 5 is 8. 40 fifths plus 6 fifths, 46 fifths, minus, let's get it all on the same base here, same fractional denominator base, is equal to, what is this going to be? This is going to be log of what? 18 fifths. Yeah. Log of 18 fifths plus 5 fifths, right? So this is going to be the log of 23 fifths here, right? Now, I think the concern is, do we have any cases where we might have a negative argument that comes about? And I don't see that we do. Now, if we just want to keep mashing with this a little bit and go back and turn this into a quotient here, what are we going to get? We're going to get the log of 46 fifths divided by 10 fifths. And what are we going to do here? Multiply by 5 tenths to clear this out. You want it that way? Well, let's just go ahead and change flip. What I'm doing fraction division here. So this is going to wind up being 46 over 5 times 5 over 10. So it's going to be 46 over 5 times 5 over 10, which is going to be 46 over 10, which equals 23 over 5 with the log in front of it. I know this is sloppy, but I'm just trying to see if I can come back to the same result here. Okay, so I can simplify down using fraction arithmetic with the same result. I can get log of 23 over 5 equals log of 23 over 5. And I don't see any negative values that would come about in any of these calculations for the argument of the log. So I'm going to say it's 6 fifths, and there's not any problem with that answer. 6 fifths. Oopsie daisy. Okay, so I seem to like that answer. Okay, well, I'm going to stop this video here, and I'm going to stop this video here.